If you had to guess where we would find the most complex eye in nature, where do you think it'd be found? Maybe an eagle comes to mind, or some sort of other animal. But it's actually found in, of all places, a shrimp. Oh, and it just so happens that this shrimp has a punch that's faster than the eye can see as well. Today, let's take a look at the mantis shrimp. Back in 1975, Roy Caldwell, a magazine editor, found his way to a marine biologist at the University of California, Berkeley. And the biologist was studying the mantis shrimp. And as he was studying the mantis shrimp, he went over to the glass cage and he began tapping on the glass, just trying to kind of provoke or get a response out of the mantis shrimp. Well, it turns out that the mantis shrimp tapped back, if you will. In other words, it punched the glass, shattering the glass and spilling water all over the floor, letting us know this mantis shrimp is actually got some pretty amazing things. Let's take a look at its punch, first of all. The speed in which the mantis shrimp punches is incredible. It's much faster than the human eye can see. More specifically, it is punching 50 times faster than the blink of our eye. And so its acceleration, if it goes from a stop to its top speed, it's equivalent to about the acceleration of a .22 caliber bullet. So when you shoot a bullet out of a gun and it goes from a dead stop to its velocity, that's how fast this punch is accelerating. Matter of fact, just in order to film it, researchers had to use cameras that were filming at 100,000 frames per second just to try to capture this punch. An incredibly fast punch. And when they found it, it was actually the fastest punch in nature at that time. They have since found some other strikes that are faster, but the difference is the mantis shrimp is doing it in water, which of course has much more resistance. And the mantis shrimp's punch is the fastest in water, an incredibly fast punch. With such a fast punch, you might also imagine that it's packing some power behind it too. With that type of acceleration and that type of speed, if it connects, it's going to do some damage, which is exactly what it's trying to do. If this particular punch lands with, for example, a crab or a snail or an oyster, it has enough force to crack the shell so that the mantis shrimp can get its dinner. If it connects with just about anything, any type of unfortunate bystander, it's going to do some damage and can kill, of course. But that's maybe not the most amazing part about this punch. See, yeah, it's fast, yeah, it has power, but since it's happening in water, it's doing something maybe even a little bit more special. It's punching with so much force and so much energy that it's actually beginning to boil and vaporize the water as it's moving through it. And so what this does is it creates an air pocket that can actually be seen at the front of its fist as it's punching, and that actually is doing a lot of damage too. See, what happens in water is when you create an air bubble, it creates something called a cavitation. Now, you probably have no idea what a cavitation is unless maybe you were in the Navy or something like that. But what that is the same thing that torpedoes do when they're launched from submarines. They create an air pocket and a shock wave that expands, and then the water falls back on it, and it's really that causes a lot of damage. And so if a submarine is chasing another submarine in the water and it launches a torpedo, and the torpedo maybe explodes next to the submarine, the cavitation can actually cause so much of a ripple effect within the water, a shock wave, that it can damage and sink the submarine itself. Even if the torpedo didn't actually connect with the submarine, the cavitation can do it. Well, for the mantis shrimp, that's also what's occurring. So it can punch, and it's hoping to, of course, to hit its prey, but even if it misses and it lands next to a fish or an oyster or whatever that it's going for, the shock wave and the cavitation can even kill its prey. That's how much power that this thing is packing with its punch. Amazing. One of the questions that comes along with this is, how is it able to punch so fast? Well, it's not actually using muscles to do this. What it will do is it actually has a type of spring and lock mechanism. So, in its arm, it doesn't actually have a spring, but it has kind of like a saddle-shaped spring that, when it's compressed, will want to spring back into place. And so it will, kind of bring its arm, its fist back. It will compress that saddle-shaped spring. It will lock it into place, and then when it releases with all of the force that we were just talking about. And of course, its club is meant to handle the impact, doesn't have any problem with that. He's not going to crack his fist or his knuckles. The club hits, no problem at all, and he gets to have his dinner. Amazingly fast. Very, very well designed here. Not only does it have an incredibly powerful punch, but it also has, as we've said, the most complex eye in nature. Well, when we take a look at the structure of the eye itself, each eye is sitting up on an elevated stalk, if you will, meaning that it's able to kind of rise up above its head, and it's able to look around without having any of itself in the way. Well, each of these stalks and each of these eyes are able to move independently. So they can twist and they can swivel. One can be looking up while the other one is looking down, and it doesn't have any problem with that at all. Not only that, but each eye is able to see in 3D. What I mean is, its depth perception is able to be accomplished with each individual eye. See, with us as humans, we actually need both eyes for us to be able to perceive depth correctly and accurately. If we were to cover one eye, it's much more difficult for us to be able to understand depth. Well, for the mantis shrimp, each eye is able to perceive depth and have that 3D vision. It's no problem at all. When we take a look at the eyeball itself, it's actually divided up into 3 sections. This is going to help with the depth perception, as we just talked about, but it also helps it to perceive different types of light. When we take a look at the middle section, it actually is the most complex and the most amazing, and it actually has a variety of rows, and we'll talk about those in just a minute. But these rows are comprised of photoreceptor cell clusters, and it has about 10,000 of these different clusters in each eye, making it very specialized to be able to see all kinds of different types of light, which are much, much more advanced than our eyes are. As a way of comparison, our eyes allow us to see 3 base colors. We're able to see red, green, and blue. And all of the colors in our world are different combinations of those 3 colors. And so our eyes are able to detect millions of different colors based on those 3. Well, while we can see those 3, the mantis shrimp can see 16. And so its world is so much more vibrant, so much more detailed, and it's able to see so many different parts of light, and its vision is so much more complex than ours could ever come even close to being. As a matter of fact, some of the light that it's able to see, we have to have specialized cameras and lenses to be able to detect. So when we take a look at that middle eye, it actually has a bunch of rows. And each of these rows is able to detect a different type of light. For example, with rows 1 through 4, it's able to see varieties of color and light, and that includes everything from ultraviolet light all the way down to infrared, which of course that's what we need our specialized cameras for, and it's able to do it no problem at all. And each of these 4 rows is uniquely designed to detect certain parts of the light spectrum that's just floating around. Rows 5 and 6 on this middle eye are able to detect something known as polarized light. Now, we have polarized sunglasses that kind of help to get rid of the reflection on the surface of a lake. Maybe if someone's fishing, they have polarized sunglasses so they can kind of see down into the water a little bit better. The mantis shrimp, those top rows, 5 and 6, are able to see polarized light just to give it one more additional and unique layer of vision. Scientists today are still not quite sure everything that the mantis shrimp is able to see. Its vision is so complex and it's able to see so much. It's kind of mind-boggling for us to really try to grasp what its world might look like. From the variety of rainbow colors and the vibrance and elegance and the clarity that it's able to see. But they have also begun studying it in some really deep levels. As a matter of fact, recently they found that the mantis shrimp is actually able to see cancer. Yeah, you heard me right. It's able to see cancer, meaning that when the mantis shrimp is looking at something, the way that light is coming off of a certain part of a body is actually indicating that it's cancerous because of the way that the light is reflecting off of those cells in that area. What they have now done is they have begun developing cameras to take pictures at various parts, at certain parts of the body to detect cancer. And not only that, but it's able to detect this cancer in the early stages before anyone has even begun showing any symptoms. And so we are learning a lot about the mantis's vision, and it's helping us to diagnose cancer much earlier than we were ever able to do before. Not only that, but they're studying the mantis shrimp's eye to help us in a variety of other visual areas. And so, of course, if we want to improve our optics and our vision, what better to go to than the most complex eye that has ever been known in the mantis shrimp. One of the problems that comes with the mantis shrimp is how is it able to process all of this information? You see, it has a really small brain. It's a shrimp. It's the mantis shrimp. And so how is it able to process all of this information and diagnose it and be able to not be overloaded by everything it's able to see? Well, scientists, quite frankly, are just not sure. They have some theories as to how it's able to maybe collect this information and process it, including kind of joining it in with the part of the brain that is responsible for memory that comes through the sense of smell. Whatever it is, we're not really sure. All we know is it's getting a lot of really complex visual information, and somehow its brain is just able to handle it. It's just able to do it. It's just been designed for this very purpose. But one of the most foundational questions is why? Why would this little shrimp down in the ocean need the most complex eye that has ever been known? Scientists there are not sure too. Well, they think it might be used for spotting a good mate. You know, I guess if it can see cancer and some other problems, it's able to tell what might be a healthy shrimp or a non-healthy shrimp. Or they think that there's some sort of visual communication that's happening in some way. Or perhaps it's using it for precision with its punch to where it's able to hit with more accuracy. They're not really sure why it would have such a complex visual system. The bottom line is, we're just not sure what it's using this eyesight for. And it doesn't really make a lot of sense that it be found in some sort of creature just at the bottom of the ocean somewhere. And yet, what blows my mind is when statements like this are said. This one was found in National Geographic, where they said, "Eyes are testaments to evolution's creativity. There are eyes that are so alien, so constantly surprising that after decades of research, scientists have only just about figured out how they work, let alone why they evolved that way." Once again, if we don't know why it's being used or its true purpose or how it would evolve something like this, then why is it being said that it evolved at all? See, it goes above and beyond what can be proven. So why make that type of statement? One of the things that constantly bothers me about the theory of evolution is the idea of how this is supposed to be a process of gaining, of survival of the fittest. So for example, if the mantis shrimp supposedly evolved about 300 million years ago, more than 275 million years before humans supposedly evolved, then why aren't we seeing other animals that have even close to as advanced eyes as they do? Why don't we as humans, who are supposed to be at the top of the evolutionary chain, have even a fraction of this type of visual prowess as they do? It would be so much more beneficial if our eyes were able to look at each other and say, I'm sorry, you have cancer, or to be able to see it much more quickly, to be able to diagnose these things sooner in each other, and to be able to help each other fight the terrible battle of cancer that is just plaguing our world and our society. How beneficial would that be? And yet we're nowhere close. It's amazing that we will say that animals like these have evolved when more advanced animals up the evolutionary chain don't have even close to this type of visual ability. For me, the answer is simple. This is evidence of our God. And that when we really take a look at the knowledge, the intelligence, the creation that He surrounded us with, it is a testament to His supreme nature. It is a testament to His divine knowledge. It is a testament to the very one that has made all of the creation that we have around us. He has surrounded us with a universe that is just teeming with evidence of His power and His existence. Well, why? Why would He do that? Because there's coming a day in which we are going to have to stand before His throne, and we are going to have to answer for what we have done, whether we have followed Him or whether we have not. The reason that we have all of the incredible creation around us is so that we can know that there is a God, that the evidence supports that there is a God who has created us. And we would do ourselves a great favor to understand what does He want from us, which of course can be found in the words of Scripture. Not everything that God has created that is a testament to His existence is found in animals. As you might imagine, He's created everything. And so in all aspects of life, we should be able to see the blueprints and the evidence of His creation. For example, how did flight get here? Well, maybe you think about the Wright brothers, or you think about over time how we have engineered the ability to glide or to fly through the air. Well, what if there was something that had flight figured out a long time ago? How would something like that evolve? There's something known as the Alsomitra vine. This is a vine that what it does is it'll worm and wiggle its way up trees until it finds its way up to one of the top sections of a tree. And then it will form a pod. The pod is about the size of a football. And contained within this little football is this. This is the Alsomitra vine's seed. Each of these seeds is encased in a clear, lightweight, and perfectly designed and formed glider. Once this vine's pod is open, these seeds are able to make their way out to catch the breeze, and they're able to glide and travel hundreds of feet to be able to, again, spread out all over the forest so that it has plenty of space and not be competing with each other. As you might imagine, back in the early 1900s, inventors began looking at the Alsomitra vine seed to try to develop aspects of flight, which is exactly what they did. You see, this glider had things figured out perfectly. The Alsomitra vine glider already had flight figured out. And so they used this to create gliders and to create aircrafts. About 20 years ago, there were actually 2 Japanese engineers that studied this seed and realized that its design was actually perfect for gliding and flying. In fact, this seed's shape has actually led to the design of some of our own aircraft, including the stealth bomber and other aircrafts that are just like that. And so it's just kind of mind-boggling to me to think that we as people have wrestled and struggled with flight for so long. And it's really only a recent invention. Yet the Alsomitra vine has had it figured out a long time ago. You see, how would something like this, again, evolve? How would something like a vine even be able to know that the concept of flight is possible? It's a plant. How is it able to know the mechanics of flight, to know lift, and to be able to have the proper balance and everything that's needed for gliding and for flight? How does something like that happen? How can evolution know that that's possible and to be able to develop something like this? It's mind-boggling, and what it tells us once again is evidence of God. In Genesis chapter 1, starting in verse 11, then God said, "Let the earth sprout vegetation, plants yielding seed, and fruit trees on the earth bearing fruit after their kind, with seed in them." And it was so. The earth brought forth vegetation, plants yielding seed after their kind, and trees bearing fruit with seed in them after their kind. And God saw that it was good. It's interesting to me that even on day 3, God had already mastered flight in the Alsomitra vine seed and of course several other aspects as well. And I mean, He created flight. He knows how it works. And even on day 3, before He creates birds, He had it all mastered out, all worked out. And here we are standing, looking even at plant life. We can see the design and the knowledge, the power of our God. Blows my mind. But when we take a look at one more plant life, one of my favorites, and one that is so unique and again screams of the existence of God, is the Venus flytrap. Any kid is fascinated by the Venus flytrap. A carnivorous plant is just mind-boggling. As you know, the Venus flytrap is known for, well, catching flies, trapping flies. And it doesn't just trap flies. Matter of fact, it usually traps, say, ants or some other bugs, but it can trap a fly as well. And why would it do this? Well, it can get a lot of nutrients from the soil, like most plants, but there are some nutrients that are really hard for it to get, or it can't get at all. Well, how is it supposed to get that? Well, it gets them from bugs. The problem is, how do you trap a bug? Well, you're a plant. So how do you have the mechanics and have everything that's needed to be able to catch a bug? Well, the first thing you need to do is to attract the bug. And so the red part on the inside of its mouth will have a sweet or attractive nectar that will have bugs flocking towards it. And so the bugs will come, and they will come and start lapping up some of that nectar. And so, okay, great, it's attracted the bug, but it's a plant. How is it even supposed to know that it's there? Well, inside the mouth of the Venus flytrap, it has several different hairs or triggers, normally about 6 or so. And when something comes into its mouth, it will bump one of these hairs or these triggers, and it will begin a 20-second timer. The reason it does this is because it doesn't want to waste the valuable energy that it takes to close its mouth. So when the bug crawls in and bumps a hair, 20-second timer starts going. If a second hair is triggered, then it will close its mouth, and it will do so in just a fraction of a second. And so what it doesn't want to do is, let's say that a rock or maybe a leaf fell down into its mouth and it triggered a hair but then fell out. Well, the second one is not triggered, it doesn't close, it doesn't waste valuable energy, no problem at all. When a second hair is triggered, it knows it probably has something. But then it also goes through a third timer, where once the bug is inside and it's trapped, it will start moving around, and if it begins hitting more of the triggers, then it knows for sure that it has a little bug in there, and it will begin then putting in digestive fluid into the mouth and start digesting what is in its jaws. It also has on the end of its jaws kind of these extended little features, or these fingers, that when they close down, it will create almost like a prison bar type trap. And so if the bug is a little bit bigger, it's going to be well trapped so it can begin digesting and getting all the nutrients from this bug. Once the bug is trapped, and once the digestive fluids have begun happening inside of its mouth, it doesn't just produce digestive juices, it actually produces antiseptic juices as well. This is going to help the bug from decaying and rotting and going bad, but it's also going to help just purify everything and make it to where it's safe to eat, because it's going to take a couple of weeks for this entire process to happen. And then once it's done, it's gotten all the nutrients that it needs. All that's left is maybe the exoskeleton of the bug. It'll open its mouth, exoskeleton will fall out, no problem. He'll start waiting for the next little buggy to come so that he can eat it too. The trap is so complex that scientists are still trying to figure out how exactly that it's working. See, it doesn't have muscles, it doesn't have tendons, and so how is it able to do this? It also doesn't have a brain. And so how is it able to process this information? How is it able to know that this is happening and to go through this entire process? And once again, how does evolution evolve something like this? How does a plant start becoming carnivorous? The process is, again, mind-boggling, and it points us to a creator that designed it, as opposed to this just happening by accident. One of the things that I love about God's creation is it's always full of surprises. Just when we think that we know something, just when we feel like we can expect something to be a certain way, God inserts something that just goes against the grain. It changes the whole thing up and tells us something unique about Him. In Jeremiah chapter 32 and verse 17, Jeremiah says, "Ah, Lord God, behold, you have made the heavens and the earth by your great power, and by your outstretched arm. Nothing is too difficult for you." No matter if we're taking a look at the universe and the stars and the heavens, or just in the creation around us here on earth, we're finding that nothing is too difficult from God. I love seeing the things that go against the grain, the unexpected that God has given us in this world, like a plant that flies, or a carnivorous plant, or a complex eye in something that it makes no sense for it to have a complex eye in. Our world is full of surprises. They point us to God. Nothing is too difficult for Him. Thank you so much for joining us for this next lesson of God's creatures that blow my mind. Hope to see you next time.